Cool. And it looks like that is recording now. Awesome. All right, so for this session, we're going to cover a couple things. So the main concepts I want to go over is like the general like CAD project structure, more higher level things like version management, and then like master geometry, so how we normally design the robot and how we keep like our whole project in the Onshape space, as well as some like good design practices. It's like parameterization, how to make parametric sketch relations, which kind of rolls or kind of references master geometry as well, but just more powerful ways to use those instead of just like giving everything a base dimension, and having everything just be like hard fixed sizes. All right, so version management. I think a couple of you, this will be a new concept, but for some of you, this will be kind of a refresher. So version management, just a general overview, is kind of like you can create a history for an entire document. So if you see here on the left, I guess this is what it would look like when you're just in a part studio. If you click this button up in the top left corner here called versions and history, you'll get this pop up. Just for reference, this is the master geometry from last year's robot. And I'll kind of talk more about what master geometry is, but for now, just bear with me. So for version management, you can see there's a long chain of these version numbers, and it goes all the way back to the start here. So there won't be any of these when you start a new version, so you can kind of see this is what the document looks like when it started. So like I said, it's kind of a history. And every time you create a version, you kind of create a snapshot of the project. So let's see. Where stuff actually starts getting added in this. Yeah, so you can kind of see there's like some base sketches of a chassis. And so every time you want to pretty much save everything in a document, be it the part studios or assemblies that you have, you can click create version up here. It'll automatically increment the name of the version. You give it a description for like what you've done to the project. And then once you save it, this will give you a long list of changes that you've made. And if you ever want to go back to something, say you made a bunch of changes and you realize you messed up really early, which happens a lot, when you're clicked onto the main, which is the current version, you can always right-click any of these older ones, and you can click Restore to Main, which will pretty much bring that old version back up to the current version of the working document. And feel free to interrupt me if I don't explain anything well, because sometimes I'm not the best at explaining stuff clearly.
So I'm looking at like main. It says there's 10 changes. If you restore like version 45 to main, does it like wipe out those changes, or does that create a different version, or what?
I'm pretty sure it'll just restore that to the main working head, and you'll keep the previous versions below here, so you can also restore those, but it'll just bring that version into the main, and you can continue working from there. It's a little weird. It doesn't actually like have any like record of that I noticed from when I was testing, so it won't like say you restored version 50 to main and have like an arrow that'll show the jump, but I've actually seen these. I don't know what an automatic update is, but well, updates are also when you have other things that are versioned and you update them into another document. So say you had parts from somewhere else and they were using version management and they're all in some assembly somewhere else. You'll keep working along with the version that you imported it as until you update them into your current document. So I guess I can, let's see. Yeah, so like I said, when you're adding a new version, it'll increment this, and you have a description. You want to make sure to be pretty descriptive here. Don't just write like updated or new version or something. You want to write like what changes you made, say like added the side sketch for the subsystem or something. So like write out like, don't be afraid to write like a couple sentences or something. Definitely be more descriptive. That definitely helps with people looking back or for your own memory, because like you can see there's like 57 versions here, and that's just when somebody made a version. You don't do that every time you say you like change one dimension in a sketch. You do this after like say adding like you can see how there's like the sketch for this whole subsystem. Sometimes you'll add whole things in and then add a version. So take it from me that you will forget the stuff that you've changed, and it can cause problems later down the line if you don't really be descriptive. All right. And so when you, or the reason you'd want to make a version is if you're making large changes and you have a feeling that like, or you're going to make large changes and you're not sure if they're going to be final. So like say you're going to add or change the dimension of say the chassis because you're thinking your robot might be a different size. That would be a great time to make a version before you do that. So then if it ends up not working, you can back up to the old version and have everything ready to go at the click of a button. So it's not exactly the most concrete thing. That there's no rule that says if you're going to do this, that, or the other thing, you have to make a version. But you'll kind of figure it out as you go. More versions isn't exactly a problem. So err on the side of caution, make more than you think you will need if you're worried about not using them correctly. Although it can get a little cluttered like this if you don't name stuff very well, but all right. So I've noticed that it's a little bit funky too. I was expecting you to be able to like right click a version. Say you created a version and you're like, oh man, I didn't really want that there. I've noticed that there's not really any way to delete them. So you're just kind of stuck with them unless I just haven't explored it deep enough. But that's also another thing to consider, that you can't delete anything. So don't just go clicking and making like 50 versions, because like empty versions. I noticed it's really easy. You can literally just click like create a version. Even if you exit out, it'll still make it, and it's a little bit annoying. So just notice that might happen sometimes. All right, and so another aspect of version management. So this is just like creating versions. There's also what's called branching. I don't know particularly how much we used this last season. I couldn't find, just in the couple of things I looked at, I didn't see any branches being used. Correct me if I'm wrong, Caleb, or anybody, or Sean, I guess, that did design, if you did use branches, but I didn't see any use cases for them. They're pretty powerful. So what branches are is if you have, what's a good way to explain this? If you have like multiple people working on the same, say, assembly within a part studio, I guess there's no assembly here, but if you have two people that are like adding their parts, say like a collector for the robot, and they're both trying out a different version of the collector, like they both design collectors and they're going to mate it in to see which one works, like fits in the robot. What you can do is add a branch. And so when you're in the versions and history tree, you can just right click on any version. So say like the one right before main, and you can click branch to create workspace. Let me open up a blank document so I can actually click stuff. So I'm just going to add a sketch. I guess that'll explain the point enough. And say extrude it so there's just something to look at. And so say you create a version, say added solid. That's a terrible description. Don't do as I say, not as I do. Don't write stuff like added thing. I've definitely seen a lot of people do silly things. Like literally they will put added thing or doohickey, but I don't know. It's kind of funny, but it doesn't really work very well. And then now I can go to that version, branch create workspace, same thing. It'll just, instead of V for version, it'll do B, and these will automatically update. You just usually leave that as it is so you can kind of see the order of how things were updated. And then write a description like, say you got two people that were trying to lighten a part. Now you can add a branch, and now in this branch you can do stuff. So say you have two people, they start at the same area. Now they both make their own independent changes within the same part studio. So they're both working kind of like a Google Docs, but they get their own version of the part. And so because I said doing lightning holes, which is not lightning like the storm, but things to make a part lighter. Oh no. All right. Now I added some holes through there. And I guess I notice Michael, and I think, yeah, you're the only one that wasn't here for the first session or doesn't know about like the base, I guess, stuff I covered in the first session about like 3D modeling and sketches and how to make 3D parts and stuff. So all the stuff we'll be talking about today, I guess, is relevant and doesn't need to understand like what I just did to create this. You'll still be able to get most of the stuff understood.
I actually do understand it because I was actually working on this in the previous summer, so I know the basics.
Oh, cool. Awesome. Thanks for correcting me. Sorry about assuming, but that's good.
It's okay.
So you have one person made their changes, and say you had another person create another branch. And now you can see you kind of have two branches side by side, and now they're no longer in the same line. So I guess if I go back to this sketch, this version history tree is literally a straight line, which is what it is. It's definitely very helpful for what we do. But now you kind of see that they're going in parallel. And so from these branches, you can also, like I said, make changes. And say someone wanted to add squares. All right, and now you can kind of click in between these two so you can look at the different branches and see what people are doing. But within these branches, you can create a version. So say finished with lightning. And now this is kind of like its own parallel branch that you can see. So instead of the main version of the document, you can have these parallel branches running, people making their own changes, trying out their own stuff. And let's see. And then you can, once you have branches and you decide, okay, I want this branch to be the main document again, you can, once you're clicked on the main, so you have to be selected for where you want to apply the changes. So then you right click and then you can merge into current workspace. And then you can kind of see the description up here, how it kind of has this branch that comes out, changes are made, and then it goes back into the main line. And so now you can see, I don't exactly know what like the shapes mean. They have a little key down here, but if you go to the main, you can see that this branch 2, oh yeah, you can even hover this down and it says merge from B2. And it has a little dotted line to show that it kind of jumped across. So now that's just kind of how you use branches to have two parallel versions on the same, either you can do it adding things to an assembly or people making changes to part studios. And that's a brief overview of that. I don't know exactly how often we'll use that because we usually have one dedicated designer working on one thing. But if you feel adventurous and you want to kind of have a couple versions of something you're working on running in parallel, that's how you do it. All right. And so the next thing I want to cover, and let me know if you guys like want time to just poke around or practice any of these or try it for yourself and ask for help, because running over a bunch of things is pretty easy, and then forgetting them right after if you haven't actually tried it is pretty easy too.
I have a question. So like branch 1, you had like, was that the one where you had different style of lightning holes?
Yeah, so we can just click on it and look at it. Yep.
So like if you tried to merge that, would that try to integrate the changes with the stuff that's already on the main, or would it kind of try to replace it?
Let me see. So, I'm not exactly sure.
Oh, I see.
Yeah,
Interesting.
so it has a couple, I'm not exactly sure what it's going to do with the two sketches, but let's see, merge changes from both. Let's see if it, yeah, so
Ah,
it does what you expect. It puts both the holes onto each other. So I guess it's a little unlike code where there won't be like a merge conflict, which is, I had a lot of those lately. So it's not going to like yell at you, but say you had parts mated in, it's like in an assembly, and you move stuff around, I can definitely see mates in an assembly breaking and being red and giving you warnings, although 2D cutting stuff is pretty easy. There's definitely ways this can mess up too. Like if you change the sketch, it'll break relations and can cause problems. I've never actually tried to intentionally break it yet, but yeah, all right, so Sean confirmed, yeah, we didn't have any branches in the last design. Thanks for checking that. I didn't want to go through every document. I looked at a couple. I'm like, you know what, they're all straight lines. Probably it was the deal. Yeah, let me try that out real quick. Let's see what it'll do. So say main version 3. Merge both I guess we're gonna say, yeah. All right, and so then let's just make a sketch. I guess, yeah, I don't know. I writing comments right now is completely useless, but I'm so in the force of habit of writing like commit changes or version changes. It's just force of habit. So I don't even know why I'm doing it, but it gets deeply ingrained to you at some point. And now let's add a couple branches off of this. Now this is why you should use branches, is because it makes a lot of cool colors and the version tree looks awesome. And then say in this branch, made that an inch. And then in this branch, we make it 3 inches. Oops, I misclicked. And then add a version. We merge, go back to the main head of the version tree, merge this in, replace with branch 3, and then try to merge this. Yeah, assembly 1 has no changes, part CDI changes. So I guess it just overwrote and took the one from the most latest branch. So, I guess that is something to consider. That I guess you're pretty much taking this version and rolling it back into the main, or whatever branch you had, and rolling the changes into the main. So I guess, I'm trying to think of a way that it could break now, because if it just takes one version and pastes it over top of the current working document, I can't think of actually how that'd break. I guess that's left for edge case testing, but I guess this is the proper way to use it at this point. Good question about that. Thank you. All right. And my Discord on Do Not Disturb for now. Cool. All right. And now one thing I guess would have been good to cover in last session, but also applies to this session, and I realized I didn't talk about, is called the rollback bar. I don't know how familiar you guys are with this. You may have used it, you may have not. I find it extremely helpful. This is kind of its own version of version management. So what this guy does is it's at the bottom of your feature tree. And what you can do is drag it up to wherever you want to go back to in your document. So this is not versionable, like you can't create a version. Well, I think you actually could create a version with it rolled back, but mainly what I use it pretty much exclusively for is, say, what's a good way to show this? Actually, let me explain variables first, because that's that'll be helpful. All right, so variables are pretty much just like equations. You can set a value, give it a name, and use it in your design. So variables are nice to have at the start of your document. So before you do anything, you'd like to have all your variables defined. Because say you created a variable here, say named it length, made 2 inches, and wanted to use it in this sketch. The way that you use them in the dimensions is the pound sign and then the name of your variable. So looky there, you can't use it because this sketch was made in the featured tree before this variable was a thing. So you can't use it yet. And that's why you'd want to define all your variables at the beginning of your document so you can use them in any of your sketches, especially when you have, like you can see in this master geometry, you just got 3 sketches, and if you don't define, all your changes are going to be within those, and if you don't define your variables before those 3, you can't use any of them. So what you could do instead is use the rollback bar. You go back in time, make your variable, make it 2 inches, and now you can roll all the way back, and you can use your variable now. And so the nice thing about variables is you can use them in multiple places. So like that could be your length. You could have 2 lengths. And now if you update this length, say to 1.5 inches, see how when you're editing it goes all the way back, so you're at the beginning of the document. Then it rolls it forward. Now it's changed. You go back, forth, you can kind of see how it updates live. It's really nice. It's like, say you had your wheel diameter defined for your robot, and halfway through the season you're like, crud, the game's going to be really aggressive, you need to change your wheel size. You could just up it in one place and not have to change a bunch of dimensions all over the place and possibly forget one, and then when you're making the robot, well, not for the wheels, but everything breaks. Alright, so that's how you can use the rollback bar. Super helpful for like equations or going back before you like made a cut to look at something else. And yeah, the key about this thing is it's only temporary, and so you can drag it to wherever you want. It's not a permanent change. It's not as big as versions. It's just to kind of go back in time temporarily. All right, and then going into the topic of master geometry. So if you were on the team last year, did summer training, or heard about design, you might have heard the word master geometry. It's kind of a buzzword. It's, when it all gets boiled down, it pretty much just means the set of 2D sketches that allows you to lay out your design and allocate space for parts and space to put things and make sure everything fits before you get it all into 3D and actually before you start designing the parts in really high levels of detail. So if you look at the master geometry for the 2023 robot, when you look at it from an isometric or the view from the corner, you can kind of almost see the robot if you know what it looks like, which is, I find, like a good mark of a pretty well-defined master geometry. And so, let's see, this is done a little differently than I like, but I can see why people did it that way. So primarily, the main parts of a master geometry has 3 different sketches. So you have your top, your right, and your front sketches. And these pretty much define, if you see, like, let's go all the way down to the bottom. Let's roll this back to just the chassis so we can look at that. A little less busy and easier to understand. So when you're creating the master geometry, so you're laying out the chassis, you can see that when you look at it from the top sketch, you kind of have everything that you'd see when you look down at the top of the chassis. So you have the drive modules in the corner, and the wheels are a circle. You have your bumpers. And let's go into the sketch so you can kind of see. And this is where you'd use like an equation. So if you had like your chassis width or length, this dimension as 28 could just be one variable. so you don't end up like changing it only on one side, or if you do end up changing a chassis and it still is going to be a square, you don't have to change it in two places, so it just eliminates human error if you're smart about how you set it up. And reduces the need for equal relations. So if you see these swerve modules, they are all defined at one point, and they're either mirrored across. Let's see. You can see these dimensions, or these relations, how all these parts were mirrored in the sketch. So that's good, but those can often break and get really convoluted because you can't really see them very easily. So that's another benefit of using equations, is you get stuff defined, you can kind of see it all in one place. So I guess chassis isn't exactly the best. Let's see. Yeah, this is a really good view of it. So from the side view, like I said, you do 3 sketches, and everything is in all the sketches just in the view that you see it from. So once again, we see the chassis again from the side now. We can see that now the swerve modules have actual height. The drive modules, this is how you'd see them from the side, so there'd be pretty much a rectangle. And then we have the tower going on here, and we can kind of see how this master geometry helps. So this area is blocked out for the swerve module, and so then we know we can't slide this tube that mounts to the chassis forward and back, because it would hit the swerve module if it's on the side. And say this wasn't exactly on the side, you could move it forward, but semantics. But you definitely know that, like, say the arm couldn't come all the way down if you sketched your battery in the front here. So we can also see another way that we use master geometry. So when Liam was figuring out how long to make the arm, you can kind of see these sketches, which are, the main positions of the arm. And you can see the scoring elements on the field, which is where we had to put the thing for lack of over-explaining. And we can see that before we did all the extrudes and put all the parts into an assembly and took a lot of time to get all the 3D model going, you can literally draw 2 lines and then draw those field elements. It's like 10 lines, it takes 30 seconds. And define them and figure out how long your arm needs to be. So that's why it kind of helps you figure out how big things need to be and where you can put them. So that's also, you can see this was another subsystem on the robot that we had to package in on the side here, and this master geometry was used extensively to figure out where we could put that thing and how far it could retract. Also, it's a little tricky when figuring out how much stuff to put into master geometry, because like I said, it's mainly aimed at being a really fast tool for packaging things, like figuring out where stuff can go. And so you could go in and sketch every single bearing or every single axle or every single 3D part or module of the swerve module, I guess. And that would technically it's something you could do, but the level of detail isn't needed because you just need to get like the block outline of things. And it's meant to be fast, as well as it later defines when you're creating, say, your subsystem. You will take the dimensions from here and you can actually equate them. Well, I guess if everything's done in the same assembly, you can actually take the dimensions from here and relate them to your part studio, so that if you change things in master geometry, it actually updates in your part. And that is a very important factor to kind of drive home. So if you're changing something in your design, so say you're designing this arm, it has to be the same size as it is in master geometry. So if you're going to change the length of something or the size or shape of something in your part or your subassembly, you have to check it in master geometry first. You have to change the size here, make sure everything still fits, because multiple times we had changed things in the part where the person was designing, say, not this, well, I don't know if this happened, but this isn't a specific slam on anybody. Say you're like designing the chassis, it's because it's one of the most pretty much easy to understand things. And so you're designing the chassis and you have the 3D parts, yeah. I have the chassis here. Say you want to move one of these tubes because you want to fit the electronics in here. So you move the tube a little bit out. And so you don't go back into master geometry and change the tube in the top sketch right here, which is where you see the update. So you don't slide it over here. You wouldn't know, say, that the arm was coming down in between those two bulkheads, or these tubes, I guess. Bulkheads is just another word for them. And then later when you go to make the robot, say the arm just doesn't go all the way down because that tube moved and it actually clashed. So master geometry is pretty much the living, breathing form of the robot. It's where everything gets finalized in regards to like how big stuff is and where it goes. And so if you ever make a change to like the size or shape of something, you have to come back and confirm it in master geometry. That was a little long-winded. I don't know if I explained it too well, so if you have questions, feel free to ask them now about that.
So is this like more or less just like a convention? Like that you can't drive your parts off of dimensions from the master geometry. Is that true?
Yeah, so yeah, you can actually like click in here and like somehow get this dimension into this. At least I don't know of a way. But you want to be, or man, I lost it. You want to be taking the dimension from here and making sure it's the same in yours. That's what I meant by relate those.
Okay, cool. So yeah, that makes total sense. Thank you.
Mm-hmm. Yeah, and so like I think you said as well, it's not a tried and true, or it is a tried and true method, but it's not like a concrete thing. There's no one way to do it. Master geometry is a convention. It's just a very helpful way we've found to make sure everything fits in the robot when you have 4 different people designing all different parts.
So basically, this is like a blueprint in order to finish designing the robot.
Yeah, that is a lot better way to put it at a high level. Yeah, so it's a blueprint. Just gives a general outline of where everything goes. Let's see, there's a lot more in this master geometry that I can expand. Yeah, and I guess that's another little advantage to the rollback bar is like you can see I just dragged it up to get all this clutter out of the way when I was just wanting to look at one thing earlier. You can't like section off parts, but when it works, it helps. Just for like clarity's sake. Yeah, and so you can kind of see like the width of the tower was defined by these bulkheads of the chassis, which are defined, I don't know if it was defined from the top sketch or the front sketch, whichever was first, but there's a dimension somewhere that drives the width of these, and if that changed, all this stuff wouldn't line up or wouldn't fit or wouldn't work, so it's very important that all of it is referenced to each other. All right. And I guess the last big important part of master geometry is how you define things to each other. So like I said, kind of with the same concept as using variables and parameters, or like these equations I was talking about earlier. The 3 main sketches in a master geometry should be defined to each other with actual sketch dimensions. So I guess let me walk through another part here. All right, and so it doesn't really matter which one you start with, top, right, or front, like the view of the three master geometry sketches, as long as you get the dimensions right. Sometimes it can be helpful to start with one based off of what you're designing, but without a design, it doesn't really matter. Like in this case, we don't know what we're making yet, if it's a chassis or an arm or something. Like, to more concretely put that in terms, say a chassis, it wouldn't be really helpful to define it from the side first. Like the top-down view of where all the tubes go would be really helpful, but say an arm, like for the 2023 robot, looking at that from the side where everything went would be really helpful, say to start from this right plane, or the chassis would be helpful to start from the top. So it just depends on what you're doing. There's no wrong way to do it. It'll all work in the end, regardless of what plane you start on. So I guess I'm really comfortable with designing chassis. I designed a couple of them when I was on the team. Like a couple of years, I ended up being the one who designed the chassis. This is what I'm most familiar with. So say, wow, that's huge. 30 by 30 inches. And then you have tubes that go down the side. Once again, you should, if they're going to be the same type of tube, you could just add like I guess, let me actually show it instead of just being a liar half the time. So like I said, roll back to the beginning when you make your variables. Why not make it a rectangle? Alright, so the tube one isn't too important. When we did sheet metal design, we'd have like the thickness of the sheet metal, which is really handy because we use 16th instead of typing out 0.0625 or writing it out every time. It was nice just to be like width. So tube width, make these related. Oh, and another thing about master geometry is usually you want to have it centered around the origin. It's not too important, but it makes measuring things and doing, well, you don't do center of gravity in master geometry because it's all 2D. Just usually a convention makes it easier, so like don't put it in the corner like me, I guess. Let's see. No, I'm too lazy to fix it. Anyways, so you have like a top sketch. And you can also rename these if you didn't know. Let's do the right. Oh man, sorry. Sometimes I mess up the controls. I normally use a 2D CAD software, or not CAD, but drawing software instead of 3D, and so I always end up scrolling and rotating when I don't mean to. All right, and so now to the point where I was talking about relations in between the master geometry sketches. So say now we're going to draw the same tube that went down the front and back of this. When we draw the rectangle, we don't just want to define it, I don't know how you define, let's say the outside one. So what you want to do is actually make a sketch relation in between these, these 2 points. We'd make these coincident, or I guess maybe coincident, maybe vertical, maybe horizontal, but anyways, they're actually related in the sketch. And so now instead of what maybe a naive designer would do is they just say, oh, this is my tube width, make it 1 inch, right? It all lines up. It's all hunky-dory. But, I mean, if you do change your tube width, this would update correctly, actually. But a better way to do this is because this edge of the tube is actually already defined in this top sketch, you can continue going along the pattern of making these related. So that now, say you only change the width of this tube, right? So you go into your top main sketch. For whatever reason, this is no longer 1 inch. This is a 2x2 piece of tubing. Now, if this was just defined with your tube width, you wouldn't have had to change it in 2 places. It's automatically related and all updates. So that's one benefit to making all the sketches. Wow, that's not right at all. Using relations in between the 2 sketches when you're drawing the same thing. Because this is, like I said, the same tube. We're just sketching it in the right plane. But for the height, that's not defined in the top sketch, so this would be a new one. I guess we could have a variable for it, but say it's 2x2. Now that guy is fully defined. So that's how you can use sketch relations in between your 3, or I guess in this case 2 master geometry sketches to parametrically update. All right. So now kind of talking about, let's see. So I'm just looking at my notes real quick. Oh yeah, that's also one thing you can do. So with variables, they don't just have to be used in dimensions. One nice thing is you can actually use them in extrudes as well. So you're not limited to, yeah, just dimensions. I thought for the longest time that you can only use them in dimensions, but I just found out you can also use them here. So instead of through all, like say you do blinds, you need to give it a depth. You can also do pound, give it an equation, give it a length as well, or a variable. Yeah, that would just be helpful. I don't know where, but anytime you use variables, you could do that as well. I'm not sure if there's any other areas you could use them. So pretty much anywhere, I'm assuming in Onshape that you give it a dimension or like a distance, you can use a variable. Don't quote me on that one, but feel free to try to break it or prove me wrong. Oh, another little nice thing that I like to do, I guess let's, is for your variables and equations and whatnot. When you have a large assembly like this, you can see, or assembly or a large part studio with a bunch of features, your feature tree gets kind of cluttered. And so one thing I like to do is add folders for things. This might already know this. You can just right click things, add a folder. I always like to add an equations folder. This is just how it managed it in SolidWorks, which is another CAD program if you don't know that we used before Onshape. It always put them in a little folder called equations. I just like it. Keeps everything organized. It's nice to have a little nice practice to keep going. And as far as, let's see what I wanted to cover. Yeah, that's pretty much all you need to know about like the first 3 weeks of Onshape and whatnot. I definitely think it'd be very helpful for you guys to run through this stuff and practice it. The version management and branches can be very cumbersome, and it can get very convoluted very quick and get kind of messy. So that's definitely something to make sure you understand the basics of and kind of click through. Kind of practice on your own. It's like, let's see, do I have that document still? I guess this guy works too. Like I said, I was just creating a part and just messing around, adding features, making branches, seeing out updates. And hey, you might find something I have no clue about. I don't claim to be a master in Onshape. I definitely am not. So definitely might not know all the tricks, but it's as much as you should need to know to get going and practicing this, at least for this season. Let's see, what would be a good practice thing to make?